This is Mr. Gillum, and today we're moving on to lesson 9, and we're going to be adding and subtracting decimals. The question says, Z wants to make 2 liters of pink lemonade for a party. She squeezed the 8 lemons she had and got 375 thousandths liters of lemon juice. She had 35 hundredths liters of cranberry juice and 1 2/10 liters of water. How much lemonade can she make? How much more or less than 2 liters will she have? Okay, so they were nice on this one. They decided to separate the questions from the information. We need to know how much she can make and how much more or less than 2 liters she will have with these materials. Okay, so again, we have 2 liters of pink lemonade to make. That's not how much she has. This is her goal. Okay, this is the goal. She's trying to make 2 liters. They used a word 8, but they had 8 lemons and got 375 thousandths liters of lemon juice. She had 35 hundredths liters of cranberry juice and 1.2 liters of water. And so when she's making this pink lemonade for a party, it doesn't say this necessarily clearly in the problem, but she's going to use lemon juice, cranberry juice, and water mixed together to make the lemonade. So what we need to do is we need to figure out how much 375 thousandths plus 35 hundredths plus 1 2/10 adds up to, because that will be the total amount of volume of the pink lemonade. So in this case, it says, how can you estimate the amount of lemonade that Z can make? Well, I could estimate 375 thousandths as 5/10 or 1/2. And same way here, I could estimate that as 5/10 or 1/2. And 1.2 is close to 1. So 1 plus a half plus a half, that would be about 2 liters. So she's going to be close, at least, in my estimate. The book says that we could do the same thing. We could round 375 thousandths to 5/10, 35 hundredths to 5/10, and 1 2/10 down to 1. So the answer will be close to 2 liters. So we're going to find out if she can make it or not here in just a second. So when it says, how can you read the amount of each ingredient in words? So you're going to actually write in words. And I tried to make sure I didn't say 0.375. I said 375 thousandths. So that's what it's asking you to do. 375 thousandths, 35 hundredths, and 1 2/10. See that THS on the end? That indicates those are part of the decimal. Okay. Find a little bit of room on your paper again here somewhere, and I want to write just we're going to just do this decimal place. We're going to start with just those 6. These are the ones. These are the tens and the hundreds. I know we talked about this earlier this year, but on the decimal side, we call this the tenths. Oops, tenths with a THS at the end. The hundredths with a THS on the end, and the thousandths with the THS on the end. You'll notice that if we went one more this way, we would have the thousands. Everybody's pretty good with the whole number measurements, but they aren't very good sometimes with the decimal stuff. If you can figure out where the ones digit is, this is tens, this is tenths, this is hundreds, this is hundredths, this is thousands, this is thousandths with the THS. So it's all based on the center number is just the whole number, the ones digits. Okay, everything on the opposite side is all symmetrical. So that's a good little review. Wherever the decimal ends, that's the word that you're using. So because 0.375 ends in the thousandths place, we would call that 375 thousandths. Because 0.35 ends in the hundredths place, the second decimal, 1, 2, we say 35 hundredths. Okay, so however many spots there are, wherever the last spot is, that's the word you're using when reading it. Okay. It says, how can you convert these different amounts to thousandths? Okay. Basically this. We have the three decimals 0.375, 375 thousandths. We have the decimal 0.35, we call that 35 hundredths. And we have 1.2, or 1 and 2 tenths. The word and indicates where the decimal goes. So when we have a whole number as well. So if I wanted to make these thousandths, what I could do is I could change, modify them a little bit, keeping the same value, but I'm going to add zeros on until I make it to the thousandths place. So now I do have 3 decimal places. I have a zero, literally means nothing. I mean, there's nothing. So I'm putting a 0 on there. We call it a placeholder. Just so that we can get to the thousandths. So now I wouldn't read this as 35 hundredths. I would say that is 350 thousandths. So 35 hundredths and 350 thousandths are the same thing. Instead of saying 1 and 2 tenths, I could say 1 and 200 thousandths now. 1 and 2 tenths and 1 and 200 thousandths are the same thing. And so the way the book describes it says I can think of each number in thousandths. By adding zeros on the end, basically, is what you're doing. Okay. How can you write an addition expression to make sure the place values line up? Okay, so when you're adding things together, like 1.2, or 1 and 2 tenths, and 375 thousandths, and 35 hundredths, when you're adding those together, really the decimal places are the most important part of your addition or your subtraction too. They must be aligned. And so when we're adding or subtracting vertically through the algorithm, you need to make sure that you're adding the numbers that match in the same digit spot. So I only want to add these 5 thousandths with other thousandths, and because there are no thousandths here, we consider that to be 0 thousandths. I'm adding only the thousandths together. I'm adding only the tenths, or no, sorry, the hundredths together. And I'm carrying because I know that I have 12 hundredths. Every 10 hundredths makes a tenth. So you may or may not know this, but 10 ones makes a 10. 10 tens makes 100. 10 hundreds makes 1,000. And it works the same way here. 10 tenths makes a whole. 10 hundredths makes a tenth, and 10 thousandths makes a hundredth. Okay, it's all based on 10. Okay, it's base 10. So when it says how do you write an expression to make sure the place values line up? If you write it vertically, you need to make sure that the decimal point is in the same spot, so you can clearly see thousandths and hundredths and tenths and wholes. Only thousandths get added with other thousandths. Only hundredths get added with other hundredths. If you align the decimal place, it'll help you to keep track of that. It says write the sum that represents the total amount of lemonade. Looks like it's 1 and 925 thousandths. So let's just add that up on the side to make sure. It says that she had 375 thousandths. She had 35 hundredths. And she had 1 and 2 tenths. When I add these together, again, thousandths only get added with thousandths, so I may need to put some zeros in. Just visually, it's just a visual practice. Hundredths only get added with hundredths. I had 12 hundredths. Well, 10 of those hundredths can make a tenth, so I'm going to put that there, and that leaves me 2 hundredths left over. That's how that works. That's how carrying works. 3 plus 3 plus 2 is 8, plus 1 is 9. And then whole numbers, we just have the 1. And notice that the decimal place stays exactly where it was to begin with. And that's why we vertically align, so that we can see clearly how much we have. So it says, how can you find the difference between that number and 2 liters? So we would have to subtract 1 and 925 thousandths from 2 to get 0.075 liters. So let's take a look at that. And this is what we are going to answer right here. How much more or less? Well, she definitely has less than 2 liters, so I need to figure out how much less. 2 minus 1.925, or 1 in 925 thousandths. Again, it's important that we understand that 2 is the same as 2.0. Okay, and coming into this year, I know some people didn't understand that, but the decimal place is always placed after the whole number if there is not one observable, meaning like 2, this number 2, we don't write 2.0, or we don't write anything else. 2.0 is the same as 2. 0.2 is 2/10. That is not the same as 2. So the big mistake students like to make is they like to put the decimal in front of the number. No, it's always located behind. If you do not see a decimal, it's at the very end. So I'm going to put my decimal in, and when I subtract, there will be borrowing to do. So on a question like this, I like to borrow. Obviously 0 minus 5 will be a negative integer. You don't know that yet, but that will be negative. You can do that, but not in a vertical algorithm for subtraction. So when I look to borrow for the 0, I cannot do that. So I look to the next one to borrow, and I can't do that. So sometimes students want to go, let's just do it both ways here. Probably what happens is your teacher asks you to borrow one from the singles and make it 10/10, because one single is the same as 10/10. And then we needed to borrow one of those tenths to make these hundredths 10. We need one of those hundredths to make 10 thousandths. And now I can subtract 10 minus 5, 9 minus 2, 9 minus 9, and 1 minus 1. So we are 75 thousandths, because the 5 ends in the thousandth spot, underneath 2 liters. I prefer, and you can do this as well if you'd like, if I had 2 minus 1 in 925 thousandths, as soon as I see this 0 here that I'm trying to borrow from, I just look at it as a whole number. Instead of 200, I have 199, and then I add my 10 to the thousandth place, and it's less steps of the borrowing. But 200, 1 less than 200 is 199. Ends up being the same thing, and I don't have to borrow. It's just one borrow, and it's just borrowing from a bigger amount. So you can do it that way as well if you've never seen that before and get the same answer. Got 75 thousandths. So I want to talk a little bit about this. We talked a little bit about earlier. It says that you see that what you know about adding and subtracting whole numbers can help you add and subtract decimals to the thousandths. What you have to make sure is that you're lining up the same place values, okay? This is a place value chart. I just made this chart earlier. So ones, decimal, tenths, hundredths, thousandths. So when you see the add-ins in a place value chart, you can see that you had zeros before the first digit and decimal, or after the last digit, if you want to keep the place value straight. You can get a completely different answer if you ignore the decimals. So it's okay to put zeros on your numbers at the end or at the beginning. That's fine, as long as you keep it, you don't put them in between the decimal and another number. So if you're going to put zeros in front of a number like 375 thousandths, it's not, you don't move the decimal place. Although it looks like you just put a 0 in front, 375 10,000ths is not the same as 375 thousandths. So the decimal doesn't move. You can put a 0 in front, but it stays in front of the decimal as well. Okay, so just be careful about that. Then it says when you subtract, you need to do the same thing. Okay, we just did this problem. You can see that it just says this is the number 2, and we needed placeholders for the decimal, and we're subtracting 1, and here's our numbers that we're subtracting. And so when we do this, we borrow 1 1 to get 10 tenths. 1 1 and 10 tenths are the same thing. We borrow one of those tenths to get 10 hundredths. We borrow one of those hundredths to get 10 thousandths. Okay, it's all a relationship of 10. 10 of one makes one of the next. 10 of one makes one of the next. Okay, 10 thousandths makes 1 hundredth. 10 hundredths makes 1 tenth, and so on. And so, for time's sake, the difference between adding whole numbers and adding decimals is this. In whole numbers, you always align the numbers on the right because that's the one place. When you add decimals, you have to align the ones, but you may need to change the numbers behind the decimal and add place